Hello everyone, welcome to the Bodhi Academy. In today's PYQ series, we are going to solve PYQs of Standard 12 Physics, Chapter Nuclei. So let's begin with the first question. Why is it necessary to slow down the neutron produced in the nuclear reactor? Neutrons produced by fission are very fast, so the energy is equal to 1 or 2. So for many fissile nuclei, example uranium-235, the fission cross-section is much larger for slow thermal neutrons. So slowing down the neutrons increases the probability for further fission, enabling a sustained chain reaction. Coming to the next question, a radioactive nucleus D decays according to the following sequence. If the mass number and atomic number for D4 are respectively 172 and 69, then find the corresponding values for D. So the mass number and atomic number for D4 are given, and we need to find the atomic number and mass number for D. So to do that, we'll use the reverse formula. So the decay sequence is D to D1 by alpha decay, D1 to D2 by beta negative decay, D2 to D3 by alpha decay, and D3 to D4 by gamma decay. So the mass number and atomic number of D4 are given as 172 and 69 respectively. So from D3 to D4 is the gamma decay. So the mass number and atomic number are unchanged. So it will be 172 and 69. From D2 to D3, it is alpha decay. So it decreases the mass number by 4 and atomic number by 2. And we are using reverse. So to reverse this, we'll have to add. So 172 plus 4 is 176. 69 plus 2 is 71. So the atomic number will be 71 and the mass number will be 176. So now from D1 to D2, it is beta minus decay. So in that the mass number remains unchanged but the atomic number increases by 1. So to reverse this, we'll have to subtract the atomic number. So 71 minus 1 becomes 70. Now from D to D1 is the alpha decay again. So mass number is decreased by 4 and atomic number is decreased by 2. So to reverse this, we'll have to add again. So it will be 176 plus 4 equal to 180 and 70 plus 2 equal to 72. So first the mass number of D is 180 and atomic number of D is 72. Now we have a sub question for this question. So how can a nucleus emit beta minus particles though it does not contain any negatively charged particles? So we know that nucleus has protons and neutrons, but during the beta decay the neutron is converted into proton, electron, that is the beta minus particles, and antineutron, and this decay increases the atomic number by 1 because neutron is converted into proton and we get one beta negative particles. So therefore in this decay the atomic number is increased but the mass number remains the same. Let's move on to the next question. In a nuclear reactor, why are light nuclei used as moderators? So in elastic collision, a neutron loses maximum kinetic energy when it collides with a nucleus of similar mass. So light nuclei such as hydrogen in light water, deuterium in heavy water, and carbon in graphite are effective moderators, and they slow the neutrons effectively and have low neutron absorption cross sections. So therefore they are used. State the law of radioactive decay. The rate of decay of a radioactive substance is proportional to the number of undecayed nuclei present at that particular instant. So mathematically we can say it as dN by dt equal to minus, and where this is the decay constant. What is the half-life of a radioactive substance? So the half-life of a radioactive substance is the time required for half of the radioactive nuclei in a sample to decay. State the unit of activity, that is radioactive decay rate. So the SI unit of a radioactive decay rate is becquerel, BQ, that is equal to 1 disintegration per unit second. So the older unit was Curie, but the SI unit is becquerel. And 1 Curie is defined as 3.7 into 10 raised to 10 disintegration per second. Next is what is meant by nuclear fission. Give one example. Nuclear fission is the process in which a heavy nucleus splits into two or more lighter nuclei and releasing a large amount of energy. Example is uranium. It breaks down into barium plus Kr plus 3n plus energy. Next one is state two differences between nuclear fission and nuclear fusion. So in nuclear fission, a heavy nuclei will split into lighter nuclei, but in nuclear fusion, light nuclei comes together to form a heavy nuclei. In nuclear fission, it can occur at ordinary temperatures and produce radioactive waste. But in nuclear fission, it occurs only at a very high temperature and it produces less radioactive waste. Let's move on to the next question. Why is energy released in nuclear reactions but not in chemical reactions? Nuclear reaction involve changes in nuclear binding energy and mass defect, releasing large energy. But chemical reactions involve changes in electronic energies and which are much smaller compared to the other energy. Hence, energy release is negligible in the chemical reactions. Coming to the last question, why are fusion reactions considered more efficient than fission? Fusion releases more energy as compared to fission. More energy per unit mass of fuel is released compared to fission and uses abundant fuels like deuterium and produces less long-lived radioactive substances. Radioactive waste is less produced in fusion as compared to fission. It also inherently safer when since it cannot sustain a chain reaction, but in fission there is a chain reaction and it is much more dangerous compared to fusion. Thank you for watching today's video. Don't forget to like, share and subscribe to the Bodhi Academy.